We're on chapter 8 now. Section 8.1 deals with variation functions. We did both direct variation and inverse variation. I think we have 3 examples to do today. So I think I just made up the problems for the first 2. They were from like the first couple of sections, but I wanted to do one of each, one of direct and one as inverse, and so I don't think I picked specific problems. I just made up my values. So the first one says y values directly as x, right? The direct variation function. So you're going to start with y, and when you see the words varies directly as or varies directly with, that tells you that you write equals k times. Directly is multiplying, so you're going to multiply k by, what are you going to multiply by? It varies with x. So k times x. And we need to find a value for k. And to do that, they give us an x and a y. So we're going to plug in 12 for y, plug 2 in for x, and we'll be able to solve for k. And then we'll plug it back in to write the function. It's kind of like when you wrote equations of lines and you solved for b, and then you plugged it back in to get the equation of a line. So we're going to put 12 in for y equals k times, plug 2 in for x. We're trying to solve for k, the constant of variation. So to get rid of the 2, we're going to divide both sides by 2, divide the 12 by 2, those cancel, and you get 6 is equal, or sorry, k is equal to 12 divided by 2 is 6. So write a direct variation function. I can't just solve for the constant. They actually want the function. So I have to go back and write y equals 6x. You should have a y, you should have an x, you should have solved for your k. I also want to do an example of inverse variation. This time y varies inversely with z. So when you say varies inversely, that tells you that you're dividing. Y equals k, variation, so is y equals k. Inverse means that I'm going to divide by z. So k divided by z. Now, like we did up above, they give us a value for y, they give us a value for z. We're going to plug those in to find k so that we can write a function. So 2 equals k divided by z, which is 4. I want to solve for k, I need to get rid of the 4, so I'm going to multiply both sides by 4. And then cancel, and I get k equals 8. So we found our constant. We now need to do what we did up there and write the function. So I'm going to put our 8 in for k. Y equals 8 divided by z. Inverse variation is divided by. They sometimes then will say, use that to solve for y if z equals 1. So if z equals 1, you'd put a 1 in there. 8 divided by 1, you would get 8 for y. So sometimes they'll give you another value that you need to solve for after you write the function. These first couple of examples didn't do that. I also wanted to do one story problem with you. So it says the dosage D of a drug that a physician prescribes varies directly with the patient's mass m. So first thing is I need to come up with what kind of equation I'm going to use, what kind of function. So D varies directly as m. So I do D varies, that's equals k. Since it varies directly, that means I'm going to multiply. K times, what does it vary with? It varies with the patient's mass, which is m. So that's my general beginning setup. Then it says that they give us that D equals 100 milligrams when the mass of the patient is 55. So I'm going to put 100 in for D and put 55 in for the mass m so that I can solve for k and get my function. So divide both sides by 55. Those cancel. And k, I'm rounding, 1.818. So I can write my function now. D, the dosage, varies. K is 1.818 with the patient's mass M. So here's an example I was just telling you. Now they give you something else, and you need to use the function that you came up with to solve. It says find D to the nearest milligram when M equals 70 kilograms. So now I'm going to put 70 in for M. D equals 1.818 times this patient's mass is 70. So 1.818 times 70. This is round to the nearest milligram, so round to a whole number. 127 milligrams is the dose for that patient.